All right, as you saw in the last episode, we put our wheels on one of the pieces of luggage so it rolls. The second part of this project is we need to now affix the other piece of luggage on top. And I've got an idea for a kind of a cam latching system on the side. It has to be fairly robust. This will be acting as one unit when we put a handle on it. So something that's got some meat and meaning to it. So let me go to the computer, show you what I'm thinking. Okay, this is actually a really crappy representation of the clamp system I've designed. There's going to be a pivoting yoke and bar, I'm going to call it. At the end of this bar here, there will be a hook. You'll have to imagine that. I was too lazy to model the hook. And what you'll do is you'll fold this down, and that hook will go into a hole on the current latching system on the luggage. So when you cam it down, it also cams down the upper box. I will then also need some sort of mechanism to hold this in the upright position, but these are all things that I'm going to do later on. I want to do this in stages. So let's go ahead and make this mechanism here and see if we can at least get a clamping force to hold the top box onto the bottom box. So I've gone around the shop and I've gathered the materials, the raw materials I believe we're going to need to do this project. That is not totally true. I did this before designing the latching system, which is something I do a lot. What do I have in the shop and can I design for that? So I had these materials, so thus the design moved in this direction. We are going to go for stainless steel on the main hook rod, if you remember. Reason I'm going stainless, I'd love to go with some titanium, but when I went to bend it into a hook, it broke. So it does not like to be bent like that where stainless steel does. But we are going to use titanium for the pivot. I am also going to be using some IGUS bearings for the pivot. Is it overkill? Yes, but I happen to have a bunch of these bearings in this size, so let's use them. IGUS bearings, by the way, here's the bag. They are fantastic. If you're not familiar with IGUS bearings, become familiar with them for your projects. They basically make some of the most high-tech plain bearings out there. They are German, so they are superior. It's all right. We are then going to first start with the aluminum parts. And I think we're going to start with what I call the pivot fork. You can kind of see the outline of it here. Again, I'm not just winging it. I have drawn up some plans here for the pivot fork. It was one of those parts where I wasn't sure if I was going to CNC it or manual it. I'm going to go on the manual mill. It's just going to take a long time to program, code, fixture, and all that when I think I can do it quicker on the manual. So let's make this pivot fork. First thing to do with this blank to make this pivot fork is we need to get the outside dimensions of our block to match the drawings. First thing though is this block is 3/4 of an inch tall. Our part is a 1/2 inch in thickness. So we're going to plane down the surface. Here we go. All right, we're on the last side of this blank, and we need to make it a very specific dimension, 1 inch, 0.786 width across. So how do I do that? Well, I already kissed this side with the end mill. This side is rough. I'm going to do a finish or a kiss pass on this, measure it with the calipers, which will be over that dimension, and then remove the difference, and we'll get our 1.786. Let's find out if that works. All right, as you can see, we are at 1.7845, so boy, 1.5 under. Completely acceptable. It was more an exercise to see how close I could get, and that's close enough for this part. So with our blank fully square and dimensioned on the outside dimensions of the part, I decided we're going to drill the through hole for the axle next as opposed to the inside cavity. That way the part is, well, we're going to do it now because the part is more rigid in this block form. So let's go ahead and drill that hole. We're going to do it with some accuracy. This is going to have a bearing pressed into it. So we're going to center drill it, we're going to undersize drill it, and then we're going to ream it. And then we're going to check it with our pins. That's how you make an accurate hole. All right, so how'd we do? So I've got 2 gauge pins here. By the way, the hole size is a 5/16. So that is a 3.3125. How's that for small numbers on the diameter? So I've got a 312 pin, falls right in. I have a 313 pin, and it goes in, but with some resistance. Maybe if I hammer it down, no, don't do that. It barely goes in. So that hole, and this is a negative gauge pin, if anyone who knows what that is, it means it's on the negative side of the size. So that hole is pretty much at 0.3125 as far as I'm concerned. That bearing will press in there perfectly. Now, for those of you with an eagle eye, there is something that's changed on this part that I did not tell you. Let's go to the counter and let me tell you what I did midstream here. All right, those of you who saw the difference, here's the part I started with. And when I drilled that axle hole, I didn't like what I saw. What happens when you model something on a computer, sometimes scale is not realistic. And you have to make the part and then go, huh, I don't like that. And what I don't like is how thin the walls are around that hole, and I'm talking about that thinness right there. This is going to be under some decent amount of force, under clamping pressure, holding those 2 panniers together. I can't tell you why, but I didn't like that. So I basically went back, remade blanks, and remade them to a slightly thicker. This was 1/2 inch, this new one is 0.65. And the meat on that wall is significant. So anyways, this part is gone. This is our new part as we move forward. Beefier, better, faster, sleeker, sexier. It will be lighter. I'll do some extra machining on it to try to get our weight back down. Or not. We'll see. Now we're going to cut the cavity in this pivot fork to give us the, well, the fork aspect of this part. So we have to do a little bit of math. We're taking a 1/4 inch end mill and making several depth passes to give us that cavity. Here we go. All right, fork pivot is essentially done. I might go back and cut out some more material, but for right now I want to see how it functions. I actually went ahead and put the pressed the bearings in on this one to see if we would have a pivot. And guess what? We do have a pivot. Good to go. The next one we're going to work on now is, of course, called the pivot base. And that's going to be made from these 2 blanks here and these drawings. Let's do it. All right, I'm going to save you the boredom of showing you where I squared up the blank, making the dimensions of it, the width, the length, and the height. what it needs to be for the part. So what we're going to do now is you're going to see me in fast motion drill and tap some holes, drill a through hole for the locking pin, flip it and drill an axle hole, and then we'll put it on each corner and put some nice radiuses on this part to make it pretty. Here we go. All right, again, my bad on the fast motion there. I'll do better next time, maybe. Here's the part. It's done. You've got 2 threaded holes there. That is what will mount it onto the luggage box itself. That little hole there is going to be for a spring pin that is going to go through there, and that is going to capture the axle that is going to go through that hole to act as our pivot. There's a little bit of interference on that axle, which is what I wanted, because the axle doesn't rotate. The actual pivot fork does. And by the way, this pivot fork has the bearings in it. That's the tolerance I was looking for. Just a little bit of interference. See how that doesn't fall off? Just slightly pinched, so there'll be no wobble on that pivot. Not allowed. All right, next we're going to do the hook. I'll call it the hook bar, the hook rod. That'll actually attach to the other piece of luggage. This is called a diacro bender. It's a tool I've had for, gosh, over 20 years. It lets you bend metal in different shapes and bends and whatnot. What we're gonna do is just basically use it to make a very simple over 90-degree bend and create ourselves a hook out of this 1/4-inch stainless steel rod. So let's see how it goes. Using a big lever, you can do an amazing amount of work. And I've got a Sharpie mark how far I wanna go, which is about there. And there you go, there's our hook. So here you can see I removed the camming buckle off the luggage. And what I'm gonna do is I'm gonna cut a 1/4-inch slot in it to receive the hook we just made. And we are gonna do that with our 1/4-inch end mill. And this is stainless steel, so we need to be slightly careful. Stainless steel can be twitchy at times, much like titanium. Let's find out. If I did this right, boom, goes in. So the hook will fall in, goes under tension, it's not going anywhere. All right, now we need to thread the end of that rod hook. And so what I'm gonna do first is I'm gonna take the diameter down to 0.235 of an inch, and then that'll let us put this die threader over that and give us an M6x1 thread. All right, diameter is dead on, so now oil the bejesus out of everything, put our die on there, back up our chuck, our drill chuck. We're using the drill chuck as an aligner. It's gonna keep this die tool perpendicular to our part, so we get nice straight threads. Here we go, and you can't use enough oil when doing this. See how it went. Perfect. All the way down. So what that's going to give us now is a part that looks like this. Got our hook, got our thread. We're getting closer. All right, a side part of this clamping project is the ability to register the 2 boxes together. As you can see right now, they can kind of slide around from each other. We don't want that. We want them to come together and be one piece, and then clamp it together. So I've got an idea on how we're going to do that. All right, so here's what I came up with to register the upper and lower box together. Did not do any modeling, just kind of winged this one. But we've got what I'll call a receiving bracket and a transmitting button. And the button registers in this little 45-degree chamfer right there, like that. So what does this mean for registering the boxes? Let's mount them up and let me show you how that works. All right, so here you can see the receiving bracket here and the transmitting button here. So how does that work? When we put the top box onto the lower box, just like Legos, they register. And now they do not want to move relative to each other once they clamp on. What's also nice is those feet act as a levelizer, or those brackets there act as a levelizer and make the box flat on the ground. So we've got only one more problem to address, and it is this. Our locking bar mechanism does not stay up, so we've got a keeping it up problem. So what we need to do is make something that'll hold it there, and I've got an idea for that. So I did model up a latching mechanism. However, I'm not going to put you through the pain of looking at that. I am going to just show you or tell you that I did make some plans. I do have my raw material, some special tooling. So in order to get this segment wrapped up, I'm going to jump ahead and show you very quickly how I made this latch and how it all comes together. With everything done on this latching mechanism, we have something that looks like this. I'm going to call this the housing. Not super complicated, but has its fair share of multiple cuts. We have a piston with a cavity or a counterbore in the center there to receive a spring. This is not the actual spring I plan to use, but it's the one I have right now. And then we've got two spring pins. So when you put all of this together, like this piston in there, the spring will go in there, this spring pin will capture that, this spring pin will go through there. You get this. Get a mechanism that looks like that, and that will of course now capture that rod from the pivoting assembly, and then it can be released. So with that done, we're going to put it all together, and let's see how those boxes do when they are bolted together with the entire assembly. All right, all the parts are reinstalled, so let's run through this. The first thing we do is the top box gets registered on that lower box so that they stay together. Then the next thing we're going to do is the clamp mechanism. Let's get a close-up of that. So then we release that connecting rod by pulling the piston in, lower this down, put that onto the lower clamp. We'll do the other side here in a moment, but just to show you how it goes back together, is this comes up, presses in, and it doesn't go anywhere, and it doesn't rattle. But anyways, let's go back to setting this up. So the first one you do like this, you don't even have to operate the clamp. Then on the other side, you release the rod, insert it into that slot, drop the clamp. You do have to lock it because it is trying to open it. So you do have to lock this one. There we go. And let's see how that comes together. There it is, done. The upper and the lower box are now one. They can be wheeled around. They don't move relative to each other. And you hear that? There's no rattling. There's no movement between the two boxes. So that's the end of this project with the clamps. What we're going to do next is the handle, because we need a handle.